Hi everyone, I'm Maddie, and today we're going to be talking about database principles for CS 1501/CSC 3950 for Unit 3.1. So I'm just going to go through an overview of what we're going to talk about today. We're going to talk about the differences between databases and database management systems. Then we're going to go into the different types of databases. Then we'll talk about some database lingo and link everything together into the bigger picture. And then we'll talk about your activity and further research you can do on databases. So what is a database? A database is an organized collection of related data, and a schema is basically the logical blueprint of how everything is constructed and how things relate to one another. Some examples could be as little as the notes you're taking for this class, or even just a file that contains data. And you can even go as big as UVA or UVA-Y to student database, and even bigger to Amazon's product database. So why do we need databases? It's really easy to store and access information. It contains details about organization or domain applications, and you can manage large amounts of data, which is also known as big data. And this is like even bigger or as big as the Amazon product database. So now let's talk about what a database management system is. So this is basically software used to create and maintain databases. And it also interacts with users, other applications, or the database itself to capture and analyze data. And so some examples of this is MySQL, SQLite, PostgreSQL, MongoDB, and Oracle. So why do we need database management systems? So this provides a way for users to access and update the database. You can't go directly to it. It gives you a way to actually communicate with the database. And it ensures the safety of this information stored in the database. And it reduces redundancy, and it has a structure of for storage of information. So like we were just talking about earlier, the schema. And it handles transactions that occur at the same time. And I'll talk about what transactions mean in a few slides. So now let's kind of just talk about, like, I said a lot of things. Let's talk about how they actually work together. So on the left here, you have apps and users, and then database management in the database. So how apps or applications or users communicate with the database is through an API, which we talked about last week. And so they get and fetch information from the API. So then the applications or users will send information to the database management system, and then the database management system will update or get information from the database and return that to the applications or users that requested information. So now let's talk about different types of databases. So a relational database is the most common type of database that we'll use. And basically it stores information as rows, which are tuples, and columns, which are attributes, into a relation, which is also a table. And so right here you see you have orders and you have users and products. So these are all tables. And then you store information in ID, user ID, product IDs, etc. All of these are rows and columns that relate to one another. So orders will relate to the users and the products. All right. And then a NoSQL database is basically it stores more of a wide range of data. And so as you see here on the picture, so it has key value storage. So you can store data as having a key associated with a certain value. You have a graph database that you can think of as, when you think of this, think of like a social networking website. You have different amounts of data that are linked to one another. And then you have wide column stores. And instead, this is like a relational database, but instead of storing databases in rows, you'll store it in large columns. And then a document-oriented database stores something like we talked about in the API lecture, they store JSON. And an example of a NoSQL database is MongoDB. So now let's go on and talk more about different types of databases. So first we have a centralized database, where you can have users and applications all interact from different places, but all only interact with one center database. And then you have distributed databases, which are pretty different. So you have data distributed among many different databases, but they can all communicate with each other through links. And then you have cloud databases, which are so basically it's hosting a virtual environment, and you can actually, we don't talk about it that much in this class, but you definitely look it up and you'll probably learn about it as you get further into your CS curriculum. And then it executes on a cloud computing platform, so something like AWS. And then we can talk about hierarchy databases or hierarchical databases. And this is basically data that has relationships between a parent and a child. And so as you can see here, there's the parent and then the kids, parent, kids. And you won't have duplicate parents here. You'll just have, but you can have multiple children with the different types of data that you're trying to store. So a network database, you can think about it as having nodes of data that are connected to one another through links. And this is different from a hierarchical database because it's not just a parent and the child. Like parents and children can have multiple of each. And here are some examples below. So now let's go into some database lingo. So a primary key is used to identify data that's unique to that database. And so two rows can't have the same primary key. And so a foreign key, which is usually just in relational databases, is used to maintain this relationship between two tables. So a primary key of a table will act as a foreign key in another table, which is shown here. So so course ID is a primary key in this table, but it's a foreign key in this one because that's how that is what creates the relationship between these two tables. And then a query is a single action taken on a database. So if you want to do something, get information or do something from the database, that will count as a query. And we'll definitely talk about queries more next week when we talk about SQL. And then a transaction is a sequence of operations or a sequence of queries that make up a single unit of work performed against a database. So if you want to aggregate data, or if you want to get certain data from the database, all this together, all the queries together to do that will be a transaction. So now let's talk about the bigger picture. Databases are used to support internal operations of organizations and to underpin online interactions with customers and suppliers. And so it also impacts many different types of industries. So as below, you can see that it impacts the health industry, billing, financial, and enterprise. And then web apps, so databases are really useful for web apps because you can make personal projects, internships, etc., and you can link a database to your web app to store information and to communicate with users. So now let's talk about your activity. So on the course website, you'll locate the Unit 3.1 assignment on Moodle, and then you'll click on the link for the activity Google Doc. And then make a copy of this document and rename it to your commuting ID database activity. And then after completing all the questions on it, submit your copy as a PDF to the submission system. So here's some further research. So you can look further into more types of databases. Yes, we talked broadly about the different types of databases, but you can definitely delve more into them if you want to. And we also didn't talk about object-oriented databases. There's many that we have not talked about as well. And then you can start looking into SQL, which is a structured query language that we'll start talking about next week. So thanks for watching, and good luck on the assignment. Bye.